As the sun approaches the horizon, you might notice that its shape appears distorted. This intriguing phenomenon, caused by atmospheric refraction, gives the sun a flattened or even unusual shape during sunrise and sunset. To understand the related phenomena, we need to explore the concept of mirages. Let's consider two main kinds of mirages. The first is the inferior mirage. An inferior mirage occurs when a dense layer of cold air sits on above our line of sight, with a layer of less dense warmer air below our line of sight. This happens frequently on hot summer days when the sun shines on a black asphalt highway, and the hot ground heats the bottom centimeters of air. Light travels slightly more slowly in denser air. So, when rays of light coming down from the sky get close to the hot air near the ground, the light rays are bent back up toward our eyes, creating a concave upward bend. Our eye and brain don't perceive the light bending, they only know the direction from which it entered your eye. So, we see an image of the blue sky, creating the familiar bright and bluish patch on the ground, or the lake mirage that people see in the desert. However, as we move closer, the mirage remains at the same distance because it's just an illusion. In an inferior mirage, the mirage image appears below the real object. There's another type of mirage called the superior mirage, and that happens when you have cold, dense air near the ground, often near the ocean, with hotter, less dense air above. In this case, the light rays are bent down, causing the eye to see the object as being higher, hence the name superior, and usually inverted than its true position. For example, imagine a ship on the ocean. You'd see the true image of the ship, but also an inverted mirage image where the bottom of the ship is at the top. When the sun is at the horizon, it can appear distorted due to atmospheric refraction. For instance, it is not uncommon to see the height of the sun to be just 80% of its width. Let's explore what causes this phenomenon. As the light from the sun or another celestial object enters the Earth's atmosphere, it bends due to refraction, similar to how a pencil appears bent when placed in a glass of water. This bending occurs because light travels at different speeds through different mediums, changing direction as it passes from the vacuum of space into the denser atmosphere. The atmosphere near the Earth's surface is denser than higher up. Therefore, the amount of refraction differs for different parts of the sun's disk. The light from the upper rim of the sun follows a slightly different path through the atmosphere compared to the light from the lower rim. The image of the upper rim is lifted a little less than the image of the lower rim. In other words, the light from the upper rim is bent more than the light from the lower one. This small angular difference creates the appearance of a vertically flattened disk. If the lower atmosphere contains layers with alternating bands of hotter and cooler air, the trajectories of the sun's light rays will be deflected unevenly. This can transform the neat ellipse of the sunset into several shapes. Sometimes it makes up flattened hourglass shapes and very seldom it resembles a square. Or even lines. Different lines of sight from the solar disk encounter patches of air with varying temperatures and density profiles. As a result, even the same part of the solar disk can be observed multiple times. For instance, as shown here, a single sunspot may appear projected in 3 different locations. If you were to observe a sunset or moonset from the International Space Station, the effect would be even more pronounced. The trajectories of the light from different parts of the moon are much more separated, sampling completely different parts of the atmosphere with very different density gradients, resulting in a strongly distorted image of the moon. These distortions of the sun's disk, along with mirages, highlight the fascinating interplay between light and our atmosphere. The bending and twisting of light rays create beautiful and sometimes bizarre visual effects that remind us of the complexity and beauty of our natural world.